and today we're going to be talking about sequences and series. So, what is a sequence? Well, a sequence is some sort of pattern like this, and this pattern doesn't have to be just adding one. It could be anything. It could be something like this. It could just be twos. It doesn't really matter as long as the sequence works. So, a couple of things that we need to talk about before we actually get started, and of course we have to start with some notation. So, some number in the sequence. Let's start with all twos. So, each number here that I've circled, and every number onwards, right? All numbers, they are considered a term, right? And depending on where they are in the sequence depends on what term they are. Looking at our twos here, this here is the first term, and we can write that as T1. Notice that the 1 is kind of small here. It's a subscript. So here, this is term 2, or we could say it is the second term. And we can write it again with this T2, with the 2 being small, again, being a subscript. And we can reference this sequence, and we can pull out any number that we want. So we can say the 100th term is 2 with our sequence of all 2's. And we can keep going like this as much as we want. So let's actually go into some actual formulas. So if we have something here where it has a common difference called D, so it's adding D each time, right? Add D each time, right? And this keeps going all the way to the end of the sequence, right? This is called an arithmetic sequence, alright? And we can actually write and express this sequence in a special way. We put our T and we say to the nth term equals A plus our common difference times the number of terms minus 1. Okay, so a couple of things. Why is n here? So n is referring to this n down here. So what it's doing is saying if you want to find the 100th term, you put timesing d by 100 minus 1. Alright? You're just subbing in. That's all that is. What is this a? So a is the starting number. So in this sequence here, at the top here, our starting number is 1. So basically, T1 is always equal to A. So the first term plus the common difference, n amount of times minus 1. So how do we work out what the common difference is? Well, you get a term, you might subtract it from the term after it. So if I want to work out the common difference between 4 and 3, that's the 4th term minus the 3rd term, and that's going to equal our difference, right? So in this case, our 4th term is 4 and our 3rd term is 3. which means our difference has to be 1. So we can now sub in, this is now 1 here in our equation, right? Okay, what's our starting number? Well, it appears to be have started at 1, so we can sub that in as well. Here's our 1. So now, if we want the 1000th term, right, we can use this formula here. It's 1 plus 1 times 1000 minus 1, so that's 999, and that's going to be equal to 1000. Now this isn't particularly amazing because of the sequence, but if we had something, I don't know, going up by 15 for example, some kind of odd number like this, so we know that the difference is 15, and we know that the starting number is 15 itself. We can now say that Tn is equal to 15 plus 15 lots of number minus 1, right? So if we want the 100th term, for example, no, let's work out the 101th term just to make things a little bit easier, right? It will be this, right? We've just subbed in the n here. We'll work out this, that's 100. 100 times that, that's 1500. Plus 15. Which is just 1500 and 15. And that's our 101st term. So, imagine that we didn't know the sequence. We didn't have this Tn equals... We didn't have this Tn plus a dn minus 1. We didn't have any of that. But instead we were given something like this. Tn plus 1 equals Tn plus d. Well, what does that mean? Well, this is called a recurrence relation. So what this does is that all it's saying is that you can work out any term that you want as long as you know what the starting term is, and you have to explain, you have to write down this bit here followed by a comma, right? The comma has to be there, and that little t1 equals a business, that has to be there as well, otherwise you don't know where to start. So this is the recurrence relation, and I told you that d is actually minus 3, right? And the starting term is equal to 10, and I want you to work out the third term, right? Using this, well, if I want the second term, I use the first term, 10, then I minus 3, that becomes 7. We can do the same thing again, so it's the third term is going to be the second term, 7 minus 3, 4. And we can keep going, right? Onwards and onwards. To recap, Tn plus a certain difference is a reoccurrence relation where T1 equals the starting number, and we have Tn equals starting number plus the common difference times the number of terms minus 1, and that's called the rule. We explained that this is a arithmetic sequence, which is just one type of sequence. And we've shown how to show what the common difference is given the sequence. So that's all I have time for today for sequences in series. In part 2 we will talk about what series is and how to use it and how to calculate it. So until then, if you have any questions, feel free to ask me in the comments below or on social media, and I will see you in the next video.